right, before we get started on going over our proofs for today, I just want to review real quickly. So, the first thing that we talked about in this unit was congruent figures. Now, this is any shape, not just triangles. There are three things that have to be true when you have two shapes, two figures that are congruent. What are the three things? Good. Okay, same shape is true. Bless you, by the way. Now, by same size, there's two things that kind of go in with that same size, and we wrote that down on our index card. Same shape and same size. What makes it the same size? Equal what sides? Congruent sides. Good. And what else? And congruent angles. Bless you. You guys are having all the sneezes today. So those are the three things that have to be true when you see any congruent figures. They have to be the same shape, so both triangles or squares or whatever. All the corresponding sides have to be the same, and all the corresponding angles have to be the same. Okay, now we talked about the 5 ways to prove congruent triangles. So do the chant. Side, 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 angle, side, angle, side, angle, angle, side. Good. If you're struggling with naming any of these things, that means you did not look over any kind of index cards over the weekend. And that's something that we want to do every single day. In order to be successful, especially in geometry type things, you have to know the properties and the theorems and the postulates and all that fun stuff. So make sure you know all these things because we have a test coming up on Wednesday. Okay, so this is everything that we have talked about. This is your 5 index cards that you've done, and we're basically only doing these 5 to get you ready for the test. Now, there's one thing that you guys need to know, and I want you to write it at the top of your notes, or if there's more room at the bottom, you can. So put you a little star and write CPCTC. And then we're going to write what that means. So those letters stand for corresponding parts of congruent triangles are congruent. CPCTC. Corresponding parts of congruent triangles are congruent. This is something that we're going to use today in a lot of the proofs that we do. So let's talk about what it means. It's saying the parts that are the same in congruent triangles are the same. So if the triangles are equal, all their parts are equal. That's basically what that says. Now, you need to either memorize this or write it in a sentence form, but if you memorize the 5 letters, you're good. C, P, C, T, C. So remember every other letter is a C, and the other parts are P, T. Okay? So you need to know that to help you with the proofs that we're going to write today. All right, so let's jump into that note sheet. We got a lot of proofs that we're going to do together, and then you guys are going to have about the same amount to do in small groups. So here we go. Now, this is called a flow proof, right? It's got the boxes. So each box is a statement, and underneath each one, we're going to put a reason. So let's look here. We're given that JK is congruent to LM. You want to make sure that you mark these things in your picture. Now, they have marked it for us. JK and LM are congruent because they have one mark. Okay? JM is congruent to LK. Why is that true? It's also given, right? There were 2 given statements. This one was the other one, so we can write given underneath that box. And notice it's already marked in our picture. JM is congruent to LK. Now, our next box, KM is congruent to KM. This is a property that we talked about in the very first unit. Reflexive, yep. Our reflexive property, and I told you guys we would be using this a lot in Unit 3, but reflexive property says the same thing equals the same thing. Now, don't forget to also mark that in your picture. KM is the line in the middle, like the line they share, right? We marked that a lot last week. You can put 3 little lines on it, so that way it's different. So now, all these things come together to make the final box. Now, what is in your final box is always what you want to prove. So you can copy what you want to prove in this final box. You can put it above it or right over top of those, question marks if you want to. I'm going to write it above the box to make it a little neater. So triangle JKM is congruent to triangle LMK. Now, anytime you prove triangles are congruent, you use one of the 5. So let's chant them again. Is it? Side, angle, side, angle, side, angle. Yes, we're trying to join a cult about congruent triangles. All right, so which one proves that these 2 triangles are congruent? Side, side, side. Good. And you can always tell by what you mark in the picture. I know those look like 5s, but I had to do them backwards. But the only thing that we have marked is 3 sides. You can also tell by the proof. This is a side, this is a side, this is a side. So it must be side, side, side. Yes, Dixie? Yes, you can. All right, let's look at our next proof that we have. If the board decides to change, it likes to freeze when I insert pictures because it is a dumb program. But it looks like on your paper, since I can see it ahead of time, we have another flow proof, right? What's the first thing that you should do? That would give you some very easy points. Look for all the givens. That's right. Look for anything that's given and write the word given underneath. Notice there are 2 given statements again. CD equals EA. And then AD is the perpendicular bisector of CE. There we go. Okay, so which boxes should I write given underneath? The very first box right here should say given, and then where else? The last box in the second row, these 2 are given. Very good. Okay, now we got to talk about this first box. When you see the word perpendicular, what do you automatically think of? What should you think about? Okay, I see you doing the hand motions, but what's maybe a word or something? An intersect. How does it intersect? A right angle or 90 degrees. Good. So when you see perpendicular, think 90 degrees or right angle, which is right here, right? So this one should be definition of perpendicular. So when it says a word, a lot of times that next one is definition of that word. The perpendicular makes the right angle. Now, let's put that right angle in the right spot. It says AD is perpendicular bisector of CE. So AD is like the horizontal, CE is like the vertical. So right here we should have a right angle pretty much at B. Now, this other word here we have bisector. What does bisector mean? It equally splits it. Well, notice this next arrow has things that are equal. It's saying that CB, this segment, equals EB, which is this segment. Well, that's what a bisector does, right? So what should we put under this box? Good. Definition of bisector. So when you have those words, a lot of times it will split it up, especially if there's two words. Perpendicular and bisector are kind of two different things. So the definition of perpendicular is to have the 90-degree right angle. The definition of bisector is split some things in half. Now, this was not marked in our picture, but you want to make sure that you mark it because that's going to help us with the next few things. CD is equal to EA. So I'm going to mark that with 2 marks. Here's CD and here's EA. So definitely mark that in your picture. Whatever's in the proof, mark it. Now, here we have triangle CDB and EBA are right triangles. How do we know that they're right triangles? They have that little box there. They have right angles, right? If they have right angles, then it makes them right triangles. This is another definition of, but it's going to be definition of right triangles because that's what it means to be a right triangle is if they have right angles. So a lot of times when you see those words, it's going to be definition of something. Would it make sense to say definition of right angle because it talked about it over here? No, because we're talking about a triangle. What makes it a triangle? The right angle. Okay, and now here we have triangles are congruent, right? Let's chant them again. What are our 5? Good job. Okay, now looking at the picture, which one of those 5 is it? It's got to be HL. You're exactly right. Because it's the right triangle, do we have a hypotenuse that's equal on both? Yep, that was our given statement. Do we have a leg that's equal on both? Yep, that was our definition of bisector statement. So that one is hypotenuse leg. It also spells the bad word, right? We don't want to make an angle side side if we're going through the list out of each other. So here we go. Let's look. Whoops, that was not attached. Did y'all see that? I just kind of threw it on the floor. All right, our next paper has a lot of little flow proofs, doesn't it? No, it doesn't. Which paper are we on? Yeah. Yes, you can. Oh, we got 2-column proof. That's what we're working on. Here we go. Here it is. So, statement 1. What do we put for the reason? Given, right? It's the same as the given. Always look for that first. That'll be an easy 1 point for you. Usually I only assign 1 point to the given statements because we just got to look for them. But whatever is given, you want to mark it in the picture. Now, first given statement says DF bisects. Again, bisects means split half equally. It splits angle EDG. So it's really splitting angle D in half, right? Well, what's over there at angle D? 1 and 2. Angles 1 and 2. Those 2 angles are congruent. Now, look at reason 2 or statement 2. What does it say? Angle 1 equals angle 2. So why does angle 1 equal angle 2? Because definition of bisector. That is correct. So remember, whatever's given, it might flow with something else in your proof. We were given that this ray bisects that angle. It's going to split it into 2 equal angles, so the equal angles would be angle 1 and 2. Now, also, don't forget to mark the other given part. DE is congruent to DG. So we need to mark those segments as equal to each other. Okay, statement 3. DF is congruent to DF. Well, that's what? Reflexive. That's this middle line that they share. That is our reflexive property. Very good. And then statement 4, triangle blank is congruent to triangle blank. So we need to name our triangle and state why. Now remember, when you name your triangle, it's got to be in the same order. Everything has to match up to write this congruent statement. So let's name our first one EDF. EDF is congruent to GDF. Very good. It looks like if we just folded that top triangle, it'd match up with the bottom one, right? So that's how you can name it in the same order. If you just folded it, it would be the same. So ED goes along the side that's congruent and then to the angle. So that's why we have to say GD. And then we go over to F, that middle line that they share. Now, why are those two triangles equal? Or do we need to chant again? Side angle side is the reason. Because we have two sides and the angle that's between them. So we have the angle that's included. Now, we have one more statement here. What should go in our last statement? What we want to prove, which is good. Angle E is congruent to angle G. Now, this is the reason that you wrote down at the top of your paper, because it says the triangles are congruent in this first statement. So if the triangles are congruent, everything's congruent about them, right? So what were the 5 letters? Look back at the front. Good. CPCTC. This can only be used after we say the triangles are congruent. So we said the triangles were congruent. So next, CPCTC. Does that make sense? If the triangles are congruent, then all their parts are congruent. All right, how do you feel about these proofs? Y'all feeling a little bit better? Are they making sense? Any questions so far? Okay, well, let's just move right along to our next page. If my board decides to work today. Are y'all glad it's comfy, cozy day? I wish this was every Monday. I'd seriously wear sweatpants like every single day. I had a teacher who laughed at me like when I was at West Oaks because I was like, yes, like we had a bunch of snow days one time. I was like, yes, it's still sweatpants day. So we couldn't wear like sweatpants to school or whatever. She was like, you are just too much in love with your sweatpants. I was like, they're so comfortable. I hate dressing up. Like somebody said, what's the worst thing about the job? And I said, dressing up and waking up early. It's not fun either. Here we go. Okay, let's talk about some more flow proofs. Now, some of these triangles might have some extra lines and things in them, so we need to maybe ignore some of them for a little bit. So here's our first flow proof on this page. So SE is congruent to SU. Sorry, it's a little blurry, but why is that true? Given. Now, remember, after you write Y, you need to mark it in your picture. So SE is here, SU is here. Those two segments are equal. All right, next we have angle E is congruent to angle U. Why? Given again. I like when it gives us lots of stuff. It makes it a lot easier. So mark it in your picture. Angles are marked with a curve. Angle E is congruent to angle U. Okay. Now we have angle 1 is congruent to angle 2. That's not given, so we need to look at our picture. Here's angle 1. Here's angle 2. Why are they equal? That's right. And vertical angles we know are congruent, so we can just write vertical angles there. And those 3 things, notice how the arrows go. The arrows give you hints. When I put those 3 together, it's going to prove that those triangles are equal. Now, why are those triangles equal? Just look at your picture. Angle, side, angle. We have 2 angles and the side that connects them. So angle, side, angle would go underneath the box. And in the box, we put the triangles. How about I call the first one ESM? ESM is congruent to USO. So E and U were the ones that were marked congruent. S has the vertical angles, and M and O are additional angles. Now, the last box is what we wanted to prove. MS is congruent to SO. Why is MS congruent to SO now? CPCTC. That's it. Just keep repeating it to yourself. CPCTC. Since the triangles are congruent, all of their corresponding parts are congruent. So corresponding parts of congruent triangles are congruent. It's a long way to say it. All right, let's look at our next proof. M is the midpoint of NO. Given. Whoops, forgot to use the pen. Given. All right, the box underneath it. M is the midpoint of WE. Given again. Now, what does it mean to be a midpoint? Splits it in half. Now, these two boxes, I accidentally reversed these. This was actually supposed to say WE here and MO here because it doesn't really make sense with the next box. But if y'all want to mark those out and put those in, you can. Yes, you can. So, let's mark these things. WE is this whole line. M is the midpoint of it. So, if M's the midpoint, then we can say that WM is equal to ME, which is the next box. So why is that true? Why does that work? Definition of midpoint. That's what a midpoint does, is it splits the segment in half. The next one, M is the midpoint of MO. Well, if it's a midpoint, it splits it in half. So this one would be definition of midpoint. So MO is this part and MN is this part. So we want to mark that with 2 marks now because it's separate and different. Then we have our last one. Now, I like flow proofs because it will tell you things about the problem. See how those both have arrows, so you have to use this box to make this box. There's no arrows that are attached or coming to this last box. Angle 1 is equal to angle 2, so we have to use the picture. Why does angle 1 equal angle 2? They're vertical angles, so we say vertical angles. And then those 3 things go into another box that talks about triangles. So let's name our triangles and say why those triangles are congruent. This is why it's really important to mark these 3 boxes that it gives us to figure out why the triangles are equal. So let's name them first. What if I say WMO? WMO is congruent to EMN. Yes. Why do we have to say E first? That's right. WM is the segment that has the 1 mark, right? So EM is the segment with 1 mark. So we have to say WM and EM first. Then N would be last. So why are these 2 triangles equal? Side, angle, side. We have 2 sides in the included angle. All right, what am I going to put in this last box? What we want to prove, WO is congruent to EN. Now, why are those 2 segments equal? Yeah, there we go. CP, CTC. Since the triangles are congruent, all of their parts are congruent. Everybody okay so far? Any questions? I know this is a lot of proofs, but I want to give you a lot of examples so that way you have some things to look at and to study by. So here is our last flow proof. We do have a few more 2-column proofs to do, but here's our last flow proof. Let's use a different color. Let's go with pink. Okay, so looking at this last one, I see these 2 little lines here. What do those 2 little lines mean? Parallel. So why is SA parallel to NE? Given. Now, you need to mark those parallel lines in your picture. So SA is the bottom line, NE is the top line. When you see parallel lines, you could come up with 4 special angles. What are the 4 special angles from last unit? Alternate interior angles are congruent. Alternate exterior angles are congruent. Corresponding angles are congruent. Same side interior are supplementary. They make 180. Good. So if you want to, you can go ahead and go to the next box from that. So if we know that information, we can say that angle 3 is equal to angle 4. What kind of angles are those? Alternate interior angles. So AIA. You can abbreviate that if you want to. If you don't remember what that equals, you might want to write it all out. Okay. Now, our next box, if we go down, SE is parallel to NA. Well, that was also given. So I'm going to mark that in my picture. These are parallel. This was given. And now notice it has an arrow to an empty box. But it's probably pretty similar, right, from the one above. If we know SE is parallel to NA, what can we prove? If we know this, what should go in this box? 1 equals 2 because alternate interior angles. Angle 1 is equal to angle 2. They're on that parallel line, so the ones that are on the side now, and that would be another alternate interior angles. You see a lot of alternate interior angles when you talk about parallel lines in this fashion. All right, the last one we have, SN is equal to SN. Well, that's the reflexive property. And we can mark that as equal to itself. I used 2 lines. I don't know why that time. You could just use 1 if you wanted to. Now, remember, mark these 3 things in your picture. If you mark those 3 things, it's going to tell you that triangles are congruent by angle, side, angle. We have 2 angles and the side that connects them. So let's say what triangles they are. What if I call it NSE? NSE. I'm using the top triangle. How would I name the bottom one? Well, think about angle N. If I'm talking about the top triangle, N is marked with 1 mark. What's marked with 1 mark down here? S. So we got to start with S. And then I went NSE, so S is marked with 2 marks. What's marked with 2 marks in this bottom one? N, and then I would go to A. So it'd be SNA for the second one. So you have to write these in the correct order and match them up. So if you want to, 1 mark, 2 marks, no marks. 1 mark, 2 mark, no mark. So NSE, SNA. All right, what's going in my last box? Good, it's what we want to prove. SA is congruent to NE, and the reason? Now y'all are getting it, CPCTC. Very good. The last 2 proofs that we are going to do, which are on the back, deal with what we call overlapping triangles. So we're going to deal with triangles that overlap together. And so it might seem a little bit more difficult when we talk about these overlapping ones. You don't see a whole lot of this, but we do sometimes. All right, statement 1. What's the reason? Given. The first reason there is given. RS is equal to UT. And then it says RT is equal to US. Notice it's not marked in the picture because the 2 triangles overlap. So we might have to draw them separately in just a minute, and we'll do that to help us with the last part. All right, ST is equal to ST, reflexive property. right now we really didn't even have to look at the picture, did we? Given, reflexive property. What's going in our last statement? Yeah, triangle RTS or RST is congruent to triangle UTS. Very good. Now, here's where we have to pause. We have to figure out, why are these two triangles equal to each other? In the proof, there's actually a hint, and I'll show you the hint in a minute. But notice these two triangles, if we were to go through and highlight them, RST is here, and then triangle UTS is here. So those two triangles overlap. Anytime you have triangles that overlap, draw them separately. Some of you are like, oh, this, I don't need to do this because I see it, but a lot of us don't. So draw them separate. Let's draw triangle RST. RST. And label it. Then draw triangle UTS. And then you mark all the things your proof told you to mark. So if you look back up here in statement 1, RS is congruent to UT. RS, UT. Mark it with one mark. Bless you. Next statement, RT is equal to US. So I'll mark that with 2 marks. And then the next one says ST is equal to ST. When you draw them separate, why are the two triangles equal? Side, side, side. So that would go in this spot. Also, you should get some hints from your proof. What's the only thing listed in these first 2 statements? Sides. We don't have any angles listed, right? So did you really even have to draw those separately? No. But we're going to see on our next proof, which is the hardest one that we will do today, that sometimes things are not listed for us and we have to list them. So in the proof, or when we do overlapping triangles, always look for things that are the same. Like when you drew these 2 pictures and when you highlighted, these 2 repeated, right? ST was equal to ST. So those 2 are the same thing. So we can mark that as being equal to each other. So if you notice your last proof, it's a lot longer and there are a lot of different things in there. So you might actually prove triangles are equal pretty early on, like in statement 3. Notice it's talking about triangles in this last proof. And then there's lots of other stuff that goes on. And also in statement 6, you prove triangles are congruent. So sometimes you got to do it twice. All right, so let's see what we can do. TE is equal to RI and TI is equal to RE. Given. Now, notice up here by the given, I have another statement. Angle TDI and ROE are right angles. Well, that's also listed in statement 5. So why don't you go ahead and put in 5 given as well? You can find those givens and write them down. That's an easy point or 2 for you if there's more than one. Now, reason 2, EI is equal to EI. Well, that is the reflexive property. And then from here, we're talking about triangles. Now, your proofs have to flow and go together. What's the only letters that I'm using in these 2 statements? The only letters I'm using are what? T, E, I, R, right? Are there any other letters? So we have to use those same letters when we talk about the triangles that are equal. So we might need to draw some triangles that have those letters in them. T, I, E, and R. What are those triangles going to look like? So what triangles is it talking about? Are these overlapping triangles or are these just ones that are there? So if I were to kind of trace out these letters, T, E, R, I, TIRE. I'm basically looking at that big picture, right? Just looking at that first statement. And then EI is that line in the middle. So is it talking about this extra D and O that's in there? No. So let's draw those triangles to the side. And you might have to do this multiple times. So here would be triangle TRI. And then here we have triangle EIR. Those are the triangles that it's talking about in these first two sentences. Now let's mark the things that are congruent again, just so we can see them one more time. TE is equal to RI. TI is equal to RE. EI is equal to EI. Marking the first two statements in those two triangles. We can clearly see the two triangles are equal by side, side, side. But now we need to name the triangles. This is why writing the triangles separately is a little bit easier to name them. So let's say that I name the first one ETI. So notice how I named the first one. I went down the side with 1 mark, 2 marks, and then 3 marks. So go 1 mark, 2 mark, 3 mark to name the next one. So how would we name this one? IRE. Yes, very good. Okay, then remember our proof needs to flow together, right? So next we have angle TIE is equal to angle REI. If the proof stopped there, it's just like the last few that we did. What's that reason? CPCTC. If the triangles are equal, why are they equal? Because their parts are all equal. Now, this is something that is not marked in your picture, and you definitely want to make sure that you go mark it in your picture. So we want to mark angle TIE. TIE is this angle here. So if you want to mark it, we're talking about that angle at I. And then angle REI is this angle at E. So it's those two parts that are now equal. Now, we already said statement 5 was given, and it's marked in our picture that that's a right angle there. And then it talks about triangle TDI and ROE. Well, now that it's talking about two different triangles, what should we do? Draw them separate. That's a great idea, is to draw those separate. So TDI goes kind of like this. So there's a right angle there at T. And we just marked that angle I had the marking on it that was congruent, and TI is marked with 2 marks. So that looks like this top picture right here. That's the triangle we're looking at. Now the other triangle we're looking at is ROE. So if we were to draw that, just drawing exactly how it looks from the picture, we have a right angle here at O. E had the equal mark, and RE has 2 lines on it. So now we're looking at this triangle. Just highlighting those a little bit better. Now, if you draw them separate and do the marks like they are in the picture, these two triangles are equal by what? Not HL. Angle, angle, side is the one. We have 2 angles and a side. HL, we need another. Oh, I just wrote HL. And for HL, we need another side. So this one is angle, angle, side. We have 2 angles, but then the side is not included. And last one. Now, why does TD equal RO? CPCTC. That would be our reason. So that one was definitely a bit longer, right? We had a lot of things in there, but anytime it's talking about some triangles, a good piece of advice, if they're not already separated or just share a line, is draw them separate. You can see a lot more things out there. All right, I'm going to put you in some small groups, and then you guys are going to work on, I'm going to call it homework, but you'll probably finish it because you got 45 minutes, but it's kind of like a proof packet that you're going to do. And after you finish one or two, call me over and I will check them. When you get to the one on the back, it's a little bit more challenging because it is like the one that we just did, but draw it out. I put worksheets up here, but I stapled them together. Now, if you finish this homework early, you can go ahead and start on tomorrow night's homework if you want to. So if you want to go ahead and get some stuff done, you can work any of these. This first page, page 308, is more about overlapping triangles. So it's about drawing them separately and see what they share. We're going to cover a little bit of that tomorrow. But then these two pages, 314 and 317, are all just review stuff. So if you want to jump to those, you can. If you didn't do Friday's quiz, it was supposed to be due today at the beginning of class. However, I'm not going to check it till 1:30. So, but that is something that you have to do later because right now we're going to work this packet in our groups. All right, let me stop this video and then I will get your groups together.